Alrighty, welcome back. I recorded the video and realized that it cut off the very top where it has the objective. So I'm re-recording this and just to say welcome back. The lesson for today is called reference angles. The objective is today I will be able to sketch angles and find reference angles. Let's continue. What is a reference angle? A reference angle is formed by the terminal side of theta and the x-axis. So what a reference angle looks like on a graph. You don't have to copy this graph down. We'll draw graphs in a second, but remember that I want to take you back. Remember that an angle theta is created by this side here. That's the initial side. And this side here. That's our important one. That's the terminal side. And so a reference angle that lives in this area here. Okay. So our reference angle is created with this terminal side here and this x-axis. So it says the angle formed by the terminal side of theta. This is the terminal side of theta and the x-axis. So, and this side here. This area here, that's your reference. We'll get more into where that reference angle lives. But from here on out, I will be referring to the reference angle as theta prime, as you see here. Theta prime means another theta, not the regular theta, but a second theta. Okay. All right, let me erase that real quick. So let's move forward. There are some things that we need to know. In order for you to figure out what your reference angle is, well, it depends on where it lands. So in the next part of this, I'm going to show you different quadrants and what that means. So this looks like a whole lot more than the last shot, but I will go through each of these one at a time. So here are some conditions, or here's a way to calculate reference angles. Your first step is always going to be to graph. Once you're done graphing, it all depends where your reference angle lands. So remember that, let's come back to quadrant 1. Let's actually start with quadrant 2. Remember that I said that a reference angle lives in this area here, right? And so it's created by this terminal side and this x-axis. And so that means that theta prime is here. Whatever the measurement of this angle is, that's your theta prime. Well, what's the best way to calculate that? The book says if you land here in quadrant 2, so your terminal side lands here. Let me erase some of this stuff. So let's say you land here. What I mean by land is this piece here. If you land in this quadrant, then you should apply these rules here. Well, it depends. Are you in degrees or are you in radians? If you are in degrees, then you will subtract 180, you would subtract your original theta from 180 like they do here. That's the rule. I know I highlighted a lot, but let's keep going. I will come back to quadrant 1 in a second. Let's look at quadrant 2. Now, the terminal side landed in the third quadrant now. So in this side of the graph, if you land here, they're saying your theta prime, or your reference angle, is calculated by your original theta minus 180, or your original theta minus pi. So it just depends. Are you working in radians or are you working in degrees? So once again, your reference angle lives here because it's created by this side and this side. All right. Now, okay, so looking at quadrant 4, if you land in this quadrant here, okay, in this quadrant, what you need to do is apply these rules here, depending again. Are you in degrees or are you in radians? If you land here after you graph your given angle, then you subtract whatever your theta is from 360 or 2 pi. Now, let's go back and look at the first one. The reason why this one is special because it says it's created from the terminal side and the x-axis. Here's my terminal side, and here's my x-axis. Well, what's my angle? Well, it's theta. And so that's what it's saying. If you happen to land in quadrant 1, your theta prime, your reference angle, that is not a good color to highlight with, but your reference angle is going to be the same as your original theta. So not much to work out there, like the second, the third, and the fourth one. Your answer is already basically given to you. Now let's look into some examples. All right, so I know that I said that we'd get into an example, but before I do, I forgot there are some restrictions. So before we go into an example, your theta that you're given must be greater than 360. Oh, I'm sorry, that means less than 360 or greater than 0. So that must mean 1, it has to be a positive number, no negatives. 2, it can't be bigger than 360. Same thing here with theta. With radians. Theta must be less than 2 pi or greater than 0. So again, it can't be negative and it can't be bigger than 2 pi. Well, what if it is? If it is, then that's what I left this little note over here for. If not, then you must first find a coterminal angle that will work. So coterminal, remember that was when we added 360 or subtracted 360 or took 360, added 360, whatever. So we'll get to that. We'll see an example of that in a second. Here we go. The first example, this is how it's going to look. They're just going to give you degrees, so 300 degrees. Another thing before we start, for these examples for today, we're just going to work in degrees. Radians is a whole other thing, and we'll get to that for the next lesson. So for this lesson, let's first graph 300 degrees. All right, so I have to start here because this is where the initial side starts. I know that from here to here is 90, here's 180, here's 270, so I got to keep going. Wow, my iPad just automatically did a circle, but I know I need to go bigger than this. So if this is 270, then I just need to go 30 more over. So let's say that's 30. So really my theta is equal to 300 degrees here. This is 300 degrees. I don't really have to put all that. I'll just say there's theta. Now, I'll come back up since I landed now in this quadrant. I landed here in this fourth quadrant. I need to scroll back up. I'm here. Okay, so what do I got to do? It says subtract theta from 360. So let's do that. Subtract theta from 360. So 360 minus theta, which is 300, and I get 60 degrees, which makes sense because we had originally said that this piece here, that was 30 degrees. So what they want to know is this part, what's left? 60 degrees. So if it's easy for you to think about it that way, or you follow this rule of just subtracting according to the rule up here, then do it that way. But my final answer is that theta prime is equal to 60 degrees. So before we go to the second example, I realized that I didn't tell you the other two steps. We did them, I didn't write them. So here they are. Step 2, determine which quadrant you are. Step 3, apply the quadrant rule. That quadrant rule depends on what quadrant you are. And those are the rules written. Negative 240 degrees. Now, how do you graph negative 240 degrees? Before you do, step 1 for this example is actually not going to be the graph. Remember that there's restrictions here. If I'm in degrees, then I know that my theta, the original problem, has to be positive. So, because it says theta is greater than 0 degrees. This negative 240 degrees is not greater than that. So it says that if not, then you must find a coterminal angle. So what I'm going to do is I'm actually going to add 360 to this and see what I get. 360 plus negative 240, and I will get 120 degrees. Now that seems a little bit more reasonable to graph. So now let me go ahead and graph that. So I'm going to start here with my initial side. I know that if I go all the way here, that's 180. That's too big. I only need 120 of those. So I can go up to about, so this is 90 from here to here. And so I need 30 more degrees. So I'll go here. Let me redo that line though. So from here to here, there's my theta, and that's equal to 120 degrees. Now, some of you are like, wait, why 120 degrees? The original problem was negative 240. But again, we can't use that because there's restrictions. It has to be positive. So I found a coterminal angle. Remember that coterminal angles mean they exist in the same exact place. It just has a different representation or a different number. So negative 240 degrees is in the exact same spot as 120 degrees. So now we kind of skipped, well, okay, we did set the step 1 up here. That was graph, already did that. Now I'm at step 2 and 3 down here. So determine the quadrant. While that's in the second quadrant, come up here to this rule here. The second quadrant is saying, in order to find your reference angle, subtract your theta from 180. So let me come back down here. I will subtract 120 from 180, and that end up with 60 degrees. And so that makes sense, again, because this little space here, that was 30 degrees. What's left from here to here? 60. So again, you don't need to really do all these steps if you kind of already see what's going on. If you don't feel like you need to do that, then don't do those things. But my final answer is that my reference angle, or my theta prime, is equal to 60 working in degrees today. So we'll do some radian examples tomorrow. But now we have 390 degrees. Now this also doesn't qualify or meet our restrictions. It actually, now we have to look back at our restrictions. Our restrictions say that it must be greater than 0, so positive, it's positive, but it has to be less than 360. We are greater than that. So what movement will we need, or what do we need to subtract from here to make it smaller? We will need to find a coterminal angle and subtract 360 this time. That's 30 degrees. Now that's not your answer. That's just your coterminal angle. So graph 30 degrees. Okay, so that's barely like right here. I'm just estimating here. I'm not actually measuring this with anything, but I know 30 degrees is a little bit below halfway. And so this is my theta. Now, which second step or third step, whatever the step was to now locate what quadrant I'm in. I'm in the first quadrant. So what's the rule? Now this next step, apply the rule of the first quadrant. Well, remember, the first quadrant is actually the best rule. That one is telling us that whatever your theta is, that's your answer. So, oh, maybe that is our answer. So, my reference angle, or my theta prime, is actually equal to 30 degrees. Alrighty, so go ahead, and if you are in 6th period, here is your homework. If you're in 2nd period, you guys voted on getting homework on delta math. So I will tell you which homework you will have to complete on Delta Math. All right, pause this video, 6 periods, so that you can get these homework problems, turn them in on Schoology as we did before. Thank you guys. Catch you on the next one.